Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today, I will talk about potential of sugarcane to be not only source of hydrogen, of polymers, but in case some people from India, from Institute for Hyderabad University Institute of Chemical Technology, design that can be due to high silica composition in the sugar cane, they can be used to for production of nanosilica, and therefore it can be used not only as a fuel source, but not only polymeric, carbon polymeric, but also nanosilica, which is very seems to be very relevant in both biomedical and for the production of replacement for different bone spars, but also a, a photocatalytical material, therefore very important to produce for making reverse photocatalytical issue for hydrogen production, also for water splitting, and therefore we can overcome we can solve the problem of many photocatalytical material. And the work was published in a recent number of biomass conversion and biorefinery under leadership of Professor Venkata Mohan, and entitled Biorefining Sugarcane Turbs for Cellulose, Nanosilica, and Biogas Production. The work used agricultural waste as we've mixed with waste mortar, employed first for dark fermentation and then biomethane production with this acetogenic fermentation due to high if methane production, if hydrogen anaerobic digestion is higher than 10%, we have hydrogenotrophic anaerobic digestion. So, firstly, wastewater burned with sugarcane was transferred to reactor for in dark fermentation, and then it was water, and this hydrogen was upgrading the methane, so giving this higher production of methane, so biofuel, and this is case. The sugarcane contains up to 8% of silica, 20% of lignin, and 40% cellulose due to research. However, it's changed due to somehow to 43 to 23 according to the conditions, according to height, soil, it can be somehow changes up to 3%. So this is the selection of the plant on Hyderabad. Materials were sugarcane turbs were collected for sugarcane to farm and Yes, such as sun already, and then dried in sun. Then when means into the 2-3 per centimeter pieces, and then chemically pretreated using hydrochloric acid, sodium hydroxide, potassium hydroxide, and hydrogen peroxide. After this, with this was prepared substance. The methodology sequential of then I was use acid pretreatment and then with silica pretreatment for recovery of semicellulose, silica, and lignin. Furthermore, delicate fibers will be subjected to bleaching and depolarization to get refined macrocellulose, which is good emulsifier in food market and important in pharmaceutical steps for binders and 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 the place where of place element of pills shells, and then after this recruiting was first processed with 1% hydrochloric acid for 2 hours at 90 Celsius. This acid washing removed materials like sodium, potassium, and manganese, and this remove in the defunctible industrial can be used for recovering these metals. In case of iron, can be used for enhancing because iron in dark fermentation helps in some age, some parts, some salts. Then desired pH was achieved was dried or to and for 18 hours or at 15 Celsius at hot air oven. Then leftover biomass was deliquified using potassium hydroxide in 75. Then, from acidic condition, was neutralized to pH 7 and by water. Then dried biomass was shifted to pH 10 to 11 at 45 Celsius. Then the mixture was passed through filter. The resulting white pulp was dried and pulverized to get refined microcellulose. During the acid hydrolysis, the hemicellulose part of was disintegrated to the hydrolyze as many monosaccharides for biohydrogen and volatile fatty acid production due to dark fermentation. So we use that in dark fermentation is only for nitrogen and hydrogen, and whereas the deliquification will recover into hydrolysis. Nanosilica hydrolyzed was if adult after this alkali hydrolyzed, some was burned in methyl for at furnace 650 in complete combustions, leaving the silica traces. Then the ash was taken into the beaker and dissolved into more sodium hydroxide solution by continuous stirring 200 watts per meter on a hot plate at 40 degrees for 2 hours. Silica, on reacting with sodium hydroxide, dissolves as sodium silicate, and the filtrate was brought to room temperature. The extraction of silica from filtrate was achieved in the acid precipitation. The old word, this silica separation, hydroxide ash, and silica solution makes nanosilica. The sugar tops are so if the cellulosic pulp was going to make the heavy cellulose and metal parts, impurities, were going into wastewater stream mixed with dark fermentation. Wastewater was containing inoculum, was heat shock, and then somehow goes for methane production, helping to this wastewater, and other for production of volatile fatty acid and hydrogen. The process can be upgrading of metallogenesis by hydrogen obtained in hydrogen dark fermentation part, and also the material has potential to become again hydrolyzed and nano silica solution. The silica oxide linkage, it's the where silica was after this using silica solution was used to chemical precipitation hydrochloric acid at 30 degrees Celsius. While gel precipitation was observed then for 18 hours. After drying 24 hours at 105 Celsius was obtained non-silica or to fine in form of fine powder. This is happening. The energy molecule you obtain in lab scale operating in lab for past 10 years. The hydrolysis obtained with dactic acid pretreatment was used for fermentation experiment. The experiment was volume 1 liter and gas holding of 0.2 liters. The reactor was maintained in a temperature control incubator at 35 Celsius with unidirectional steering. The pH was 7 using sodium hydroxide. The hydrogen was and methane production was with retention time of 72 hours. The silica, the sugar cane constitute carbohydrates and lignin was performed by hyperc according to NAL protocol. As results, the composition analysis revealed that was 40%, 23%, and 8% of silicon. The experimental section was uh, resulted in yields of obtained refined microcellulose oil on 81%, so 0.33 grams uh, of refined microcellulose per gram of sugar cane uh, per gram of sugar cane and 0.04 gram of nanosilica per gram of sugarcane, which was 54%. So both quite high efficiencies. The biogas composition was measured in 3 times, was in case of volatile acids containing in 72 hours, in first 24 hours, were not volatile as produced. However, was produced and first in 50% of hydrogen and 50% of hydroxide. Methane production occurred after 72 hours. After 24 hours was also produced some acid. Firstly, in the research was one volatile acid gram per liters, and after 72 hours was 3.5. The huge amount of 50% was up to 40 hours acetic acid and butyric acid was containing one or highest in 40 to 8 hours. In case of 72 hours, the acetic acid was containing 72% of liquid part. In case of gaseous part, the hydrogen production was still up to 72 hours, 50% of gaseous mixture, whereas the methane was just 2% in 72 hours. So this caused that carbon-rich steam was composed of sugars of xylose, amylose, and glucose, so mostly xylose. So this shows that xylose is more leading, shifting the process to acetic acid than in case of glucose. There is a case. Yeah. Nearly 1.4 plus 0.005 liters was used as biohydrogen production at 24 hours, was gradual. And after 62% of biogas was hydrogen, and was overall 303.75, whereas 1.4 liters was produced in these 2 hours. It shows that the production was nearly this 33%. So very good results were obtained. The volatile fatty acid was also high, with of increase of acetic acid. In case of anaerobic digestive reactor, this time of 3 hours, 3 days, was that methane was in 24 hours half price when one third was hydrogen. The 2% of hydrogen was obtained in 2 hours, whereas 1.5 milligram per liters of methane was produced in this process, leading to 80%. So this was very high. The substrate degradation, which 80% after 72 hours, while water acid would reach, in this case, 3 milligram per liter. This shows high efficiency of the process. So as conclusion, thank you very much for giving me for result, and we see how was efficient the methods of of changing and mostly limited for hemicellulose waste and leading to product cellulose to products the fiber microcellulose and nanosilica. This show how the way that can be obtained of hydrogen, methane, and other compounds and volatile acid in industrially interesting outcomes. So thank you very much for listening to me.